So with that, it is my honor to introduce Sorelle Friedler, who is an associate professor at Haverford College, just outside Philadelphia in the United States. She is also an affiliate at the Data and Society Research Institute. She is a co-founder of the ACM Conference on Fairness, Accountability, and Transparency. I did get to see her on stage at the event in New York. I was a little too in awe to introduce myself at that point, but earlier this year, I guess, we were both part of the workshop on data science in the liberal arts in the United States. Sorelle's research focuses on the fairness and interpretability of machine learning algorithms with applications from criminal justice to materials discovery. And she has incorporated these ideas into introductory computer science, data science, and algorithms courses. So with that, please join me in welcoming Sorelle.
Hi, folks. Thanks for the invite and the welcome. I'm Sorelle. I'm a computer science professor at Haverford College, and despite the sort of other affiliations I hold, I'm here in that capacity to talk about some of the things that I've been trying out in my own teaching recently and over the past few years, and along with some colleagues. I also wanted to emphasize, right, that I am in the US, and this is very much from a sort of US context. So I hope that it'll be more broadly applicable. Some of the examples I'll draw on are very obviously sort of worldwide, but some of them are more specific to sort of a US criminal justice context, since that is some of what I study. So with those caveats in place, I wanted to start by sort of mentioning some of the motivating examples that I think have driven me and many others to think about incorporating ethics questions into machine learning classes, and in my case, also into data structures classes. So there are increasingly these algorithms in the US known as risk assessment algorithms, and I believe they're also in use in Europe and other places, that are giving judges sort of advice on whether or not someone is risky, in the sense of whether or not this algorithm predicts that they might commit another crime if they are, say, released from prison or not held pending trial. Often these are in the pretrial context. And there are increasing calls for human oversight of these algorithms, interpretability of these algorithms, and fairness assessment. And I'll talk much more about that in a little bit. Especially in a machine learning context, right, there are also increasing calls to recognize that facial recognition accuracy differs by race and gender. There was a prominent study by Joy Bullingwini and Timnit Gebru a few years ago that demonstrated that these technologies don't work as well if you're not a white man. There are also ethical questions that surround simply the use of many technologies. And here, I think this starts to go much beyond just machine learning. There are concerns about, for example, broad surveillance mechanisms that are driven by big data, right, which relates to machine learning, but can go beyond it. And then there are also concerns relating to AI, but again, going beyond AI, about the way that what we do in our sort of online lives and on our computers impacts the real world in terms of the environmental impact. And so, one of the things that I'm interested in as a teacher is how do we get our students to start to think about these complex issues and to start to hopefully take responsibility for them. And when they go off into their lives as programmers or whatever else they decide to do, hopefully start to take on some of this responsibility and gradually change things for the better. And so what I wanted to talk about today is mostly just some sort of examples of how we can do this in the classroom. And as much as possible, I'll try to sort of talk through how I think about these things and why I've chosen to do certain things. But I also just wanted to give you all sort of a more in-depth taste of like what something like this could look like. And then I'll also talk about, obviously, what some of the challenges are with doing that. But I wanted to start by sort of addressing the elephant in the room, which is that I'm going to talk today in the context of a data structures class when this workshop is really a little bit more focused on machine learning. So did I miss the message? Why am I doing this? I thought I would address that first. And my case to you for why you should not just focus on your machine learning classroom, but actually think down to the intro level curriculum. And I think especially to data structures, where I think this is really relevant, is that it provides some useful background for machine learning that makes our lives easier when they get to our machine learning class, right? So one of the things that I think is really important is just that students have seen data in the way that we would usually think about data in a machine learning context before they get to machine learning, right? It's also, from the perspective of data structures, really useful to integrate that, right? Because it keeps these data structures ideas from being sort of abstract heaps, right? And turns them into data structures that can give you information about real world context, real world data that you might actually care about, right? It's much more motivating for data structures. And it means that when you give students a data set later in their time, say in a machine learning class, they already understand a little bit more about how do you store data, how do you manipulate it, right? How do I ask queries on that data? And so that, I think that those two things go nicely together. I think that also it's really important, sort of in a spiral curriculum style way, that students keep seeing these questions over and over again, right? So, as there's been sort of increasing interest in introducing ethics related concerns to a machine learning class, I think it's really helpful for students to have at least heard about these concerns earlier, right? They might not be able yet to fully understand the mechanisms, right? That, for example, they might not understand exactly what the problem is with facial recognition, right? And why it is that it has these disparities, but it's useful if they have some sense that what they're doing in computer science impacts the real world, so that when you come back to it later, it's not as much of a surprise. And I think, again, it's really useful specifically in data structures because it introduces students to the idea of data, but also because it's early in the curriculum, right? And it's required, at least at my institution, but I think at most. And so it's a way of really integrating this into the curriculum so that all students see and think about these ideas, whether or not they take a machine learning class. And I would also argue, and I think this is very obviously just my opinion, but I would argue that data structures is the first class where students really start to think about themselves as problem solvers, where you really give them sort of problems and say, go ahead and solve this. I think that this, becomes even more true once you get to machine learning or an algorithms class. But I think that seed is sort of first planted in data structures. And I think that that is both, for me, what's really exciting about computer science, right, is that we get to go into the world and think about the various problems that we encounter and then try to use the tools that we have to help solve them. But I think it is also what can be very dangerous about a computer scientist mentality, right? Is this idea that this small set of tools, honestly, that we know how to handle can solve such a vast array of problems. And so I think that's also, right, when we're teaching students to do that is also when we need to teach them to be really careful about how they do that, right? That it's part of that responsibility of thinking of ourselves as problem solvers to also be really careful in how we solve that problem. And then the final reason that I think it's useful to do this so early in the curriculum is that there's evidence from the sort of educational research literature on computer science education that when students are given a curriculum that is really a sort of a community-driven focus, that helps to broaden participation in computing. And, there hasn't actually, as far as I know, been specific research on integrating ethics, right? And that broadening participation. So we can't yet say that, necessarily these specific interventions will help broaden participation, but I think it's reasonable to hypothesize that that might be the case. And so I hope that that's true, right? And what I found in teaching some of these lessons is that sort of broadly students are interested and excited about them and are surprised at the important connections that they find to the real world and to other things that they're interested in their life, which I hope motivates them to stay in computer science. And so when I'm thinking about this type of curriculum, right, obviously data structures is a core class in a computer science curriculum, and there's topics that the students need to learn, right? And so that is obviously one of the primary goals, right? Is just teaching them about data structures. And then teaching them about that in a way that also connects to ethics and connects to data in a way that is hopefully natural, right? Based on the assignment. And when I'm thinking about the sort of ethical focus, I think about sort of three aspects of that. And at the intro curriculum, the one I'm primarily focused on is impact, right? My hope is that students will be seeing these ideas later in the curriculum, right? Like I said, sort of in a spiral curriculum style way. And so if in the intro classes, we can simply teach them that the choices that they make have an impact, right? That there are different choices that they can make and that those have an impact in the outer world, right? And if we can teach them that, they should think about ethics as an additional form of analysis, even though, these three things might seem like they are not yet saying, okay, now you can go forth and make the world a better place, right? These might seem very introductory, but I think that's appropriate at this level. Okay, so now I want to talk a little bit more in depth about a few things. So first I have to acknowledge a whole bunch of collaborators who have worked with me on this, right? This is not just my own work. I have a bunch of collaborators who have taught from these materials, who have also developed parts of these materials across Haverford and across Brown, and across computer science and environmental studies. I'll get to the environmental studies part in a minute. So the first thing I want to talk about is racial bias in algorithms. And I think that this is something that I hope that folks who are teaching in machine learning are familiar with these days. And again, this goes back to the risk assessment algorithms that I was mentioning at the beginning. And a lot of, I would say, why so many of us are familiar with this problem is because of this ProPublica article from 2016. But in case you aren't actually familiar with it, I wanted to give a sort of a quick refresher. So this machine bias article is sort of part of a series, but this one was about risk assessments. And so again, risk assessments are these algorithms that are used to determine whether a defendant is risky and determine whether they should be held in custody or potentially released with bail. And the process starts off with sort of a questionnaire, right? So the defendant or their lawyer is asked to answer a bunch of questions. The results of these are fed into, in this case, a proprietary algorithm. And what comes out is a set of scores across a number of different aspects, right? So there is often a separate violence riskiness score versus a failure to appear at trial score. These might be between 1 and 10, but then they might be bucketed low, medium, high, right? And then there's the part sort of below tries to indicate what factors might have gone into this assessment. But there isn't actually full visibility into the algorithm, right? So we don't actually know how these things are weighted or even what type of model is being used. And what ProPublica found is that this prediction failed differently for Black and white defendants. So Black defendants were about twice as likely as white defendants to be labeled higher risk, but not reoffend. whereas white defendants were about twice as likely essentially to be given the benefit of the doubt, right? To be labeled low risk, but go on to reoffend. So the failure rates were different by race for this algorithm. And this prompted a lot of examination in the research community also about, what does this mean in terms of fairness? Why might this be happening? And, I think that those questions are interesting and complicated, right? In a data structures context, we don't quite get into that fullness of that discussion. And what we were really focusing on in class is just trying to replicate this. So I guess, whoops, wrong way. There we go. So what the sort of class assignment, what I tried to do in this class was to structure things around a programming assignment, right? Partially because I think that is, one of the things that really makes students pay attention, right? It's a large motivating factor in a lot of these classes, partially because that is in some ways the most helpful for my colleagues who are teaching this. This is a class that's often shared amongst a bunch of different faculty and rotates between instructors in different years. And so I think it's nice to be able to pass on a large programming assignment to my colleagues. But also because in this context, one of the really remarkable and wonderful things that ProPublica did for the research community and the teaching community here was they released all of their data, right? Which means that even at an introductory level, it's possible to replicate this chart, right? And so the main thing that students do in the assignment is replicate that chart, which means that they need to learn how to read in the data, right? How to process it and store it. And then after that, they need to be able to iterate through all of the rows of the data. In the context in my class, this is an object-oriented class, and we're teaching in Java, right? So they need to figure out how to store each of the people as an object, right? And then figure out how to have a collection of objects, say an array list, that they can iterate through with some if statements to carefully sort of check which category people fall into in that chart, right? And then after that, it's a simple counting question, right? To be able to replicate the chart. And so all of that obviously serves some important data structure goals, right? Of understanding object-oriented design, understanding how to store data, right? Understanding for loops and array lists and if statements, right? All of those sort of basic assignments. This is one of the first assignments that we give in this class, which is the first time that they've seen Java. And then, what I think is the perhaps more interesting part of this is that, once they've been able to replicate the analysis, we also ask them to think a little bit more about the data. So the way that ProPublica did their analysis is looking at they give sort of a Boolean indicator value about whether or not the defendant in their data set recidivated. And recidivating means recommitting a crime, but that's not actually measurable, right? Because we don't know what people do, right, if they weren't caught. And there may be people who were caught who didn't actually commit the crime. And so what is actually measured is whether the person in the data set was rearrested within 2 years, right? So it doesn't include, it includes them even if they were arrested but not charged, right? Or arrested but not convicted. It does not include them if they were arrested and convicted after 3 years, right? So, so there's, this is not a perfect measure, but it also includes them even if they were arrested on charges that might not be charges that we care about given the context, right? So we might decide, well, actually, this is not an arrest that I think should keep someone in prison pending trial, right? I think that even if we knew that they were going to commit this crime, they should be allowed to be released, right? It's a judgment call. And so what we ask students to do is look at the various charge descriptions, right, that people were arrested for, and decide, how do you actually want to measure recidivism? And then once you've changed that, go back and re-replicate the analysis, which is not to say that the sort of fundamental disparity that was found by ProPublica would necessarily change, right? The goal here is really to get students to think about the way that these particular choices of how things are measured in data might affect resulting analyses. One of the things that's been really tough about all of that is that, as I sort of caveated up front, right, it requires an understanding of a very specific US context, which not all of my students, even though I'm teaching in the US, necessarily have. And it requires a context of an understanding of the racial disparities present in US policing, right? Which goes back to slave patrols and a long history of purposeful control based on race. And so, I am teaching a computer science class, right? And so it's not really the place to have sort of the longer historical conversation, but it's also not really possible for students to understand what they're being asked to do in this assignment without at least some of that conversation, right? And so I wanted to highlight that as something that I think is a little bit complicated about teaching to these topics. One of the things that I try to do is explain to students also that there's additionally a history of risk assessment specifically that also comes out of that same racist history of trying to control Black people within the US, right? And so, there's this much older sort of early 1900s risk assessment that I think is useful for sort of helping students to understand that point, because if you look at these social types that are going to sort of gain defendants some number of negative points in terms of their risk assessment, you'll see that it includes things like gangster and ne'er-do-well, or farm boy, which is going to get you a much more favorable risk assessment. And, so these things have sort of always been pretty subjective, right? And I think that looking at these sort of historical risk assessments makes that a little bit more obvious to students. It's also important for students, though, again, it's a lot of context for them to understand, but I think it's also important to understand that these risk assessments are only one step in the process, right? And it's a much longer process, right? So the one step is sort of highlighted on the left there in orange. It's a much longer process, and there are chances for bias to be injected into the process sort of throughout. And so, part of the way that I try to help students understand this is, again, to sort of go back to exactly what the modeling question is and what the data is, and try to understand the various places just from looking at the data where their data might be inaccurate, right? So when we're modeling risk, when we're talking about that, what we're supposedly saying is, okay, we want this goal to identify risky individuals, and we're going to have some formalization of that, right? We're going to have X and we're going to have Y, and we're going to find some function, f of X equals Y. And then I ask the students, what problems or questions do you see with this formalization? And we try to sort of brainstorm a bunch of places where these things could have gone wrong. And so I'll give you, some examples of that, though obviously in a classroom, this would be sort of a richer discussion, right? So, determining X, right, deciding what features about a person are going to be used to determine if they're risky is obviously itself a critical choice. And, often one of the key things that's included, and one of the things that's included in the ProPublica data set that the students examine, is the number of prior arrests, right? Now, of course, an arrest itself is not necessarily an indication of wrongdoing. And so if that arrest data is itself biased, then this is a way that this system sort of compounds itself. I already sort of mentioned the issue with Y, right? That sort of recidivism is actually unmeasurable. And then we also talk about the way that the evaluation of the function itself, right, sort of assuming that all failures should be treated equally, may also be a problem. And overall, sort of what I'm trying to get them to think about is this assumption that the data is correct and true, right? Because one of the things I think is really hard for students when they're first looking at and analyzing a data set is to understand that all of that data that they're looking at was created, right? That someone chose exactly how to measure each of these things, that they're the result of human observations. And that's also why I also show students that survey form that I showed you all sort of at the beginning of talking about this, so that they can see, you know, these are the types of questions someone was asked, and they can think to themselves, well, would I necessarily have answered that honestly, right? Maybe that answer actually would have required a paragraph, and I was just given, you know, 2 choices, so that they can understand sort of the messiness of data when it's about people. I've also put together a bunch of resources for my students, which I'm also happy to share with you all, because I think that it's important to have, you know, for students to be able to get more of this background, right? So I give them a bunch of readings, but we also show the ProPublica article and the ProPublica authors put together a video description of their article. So in addition to having students read the article, we also show them the video. And then one of my students, Steve Lee, put together about a 5-minute video on the societal background, right, going back to slave patrols and the history of policing in the US, so that students could have some of that background, right, without necessarily having the time to do sort of the full reading. And then we haven't actually tried this out yet, but this year we're going to try to also do sort of an in-lab discussion where we try to draw out some of these issues to make sure students understand a little bit more what's going on in the data set that they're examining. Okay, so switching gears a little bit. And again, this one I think is sort of more obviously international context. One of the other, I think, critical ethical issues that I certainly want students to encounter is that of the environmental impact of what they are doing, right? Environmental impact of code. And one of the things that I find that students have a lot of trouble with in that is that they've really been taught to believe that computers are not really physical objects, right? There's this idea, you know, and I think this is especially now that Wi-Fi is much more prevalent than it was when I was a child, right? There's this idea that the internet can sort of fly through the air, right? And all of this language about computation happening in clouds, I think also encourages this idea that computers and the internet are not actually physical objects, right? And so how could they have any environmental impact? They're just sort of our own imaginings. And so I try to sort of start by breaking this down, also because I don't think any student should leave intro computer science still believing that the internet flies through the air. So that's also a pedagogical goal, but I try to sort of start by helping them understand the physicality of computation. And so I'd like to show them this chart. Whoops, weird. Looks like we're missing the link to the fun quote /context, sorry. But I like to show them this chart of submarine cables so that they can see how it is that we are all connected via the internet, right? And specifically, I like to encourage them to think about that the internet can break, right? That these cables under the ocean can break, and that's the internet breaking. And when that happens, somebody needs to go and physically fix it, right? And you know, that's obviously also useful to understand from a computational perspective, right? If we're thinking about optimization and how do we get email sending to be faster, right? It's important to understand that when you're sending an email, it needs to actually physically travel from one part of the world to the other. But I think from an environmental perspective, it's also just useful for them to understand that these are physical objects, right? That we are intervening on the ocean floor by laying internet cables across continents. And, I like to suggest, and maybe I'll start requiring, though I haven't yet, that they read this article, The Environmental Toll of a Netflix Binge. It's a beautifully written article that I think is also just very clever in the way that it connects these issues of sort of the physicality of clouds, right? And what that means for the environmental impact of a Netflix binge in this case, or generally of the computations that we run. There have, from sort of again, a more machine learning standpoint, there have also been increasing studies, right, that show that the various models that we're training can be incredibly impactful in terms of the resulting CO2 emissions once you trace through from the energy usage all the way to CO2 emissions. And that's exactly what I'm going to talk about a little bit more in depth. And in fact, just recently, a few days ago, there was a big article in the New York Times talking about Bitcoin and how Bitcoin and the electricity usage is also going through the roof. And sort of, right now, Bitcoin takes, I think it's more than 7 times as much electricity as all of Google. And Google also takes too much electricity. They were sort of in this article comparing it to various countries, right, showing that Bitcoin is using more electricity than many countries. And so how is all of this happening, right? What does, our coding on our laptop have anything to do with CO2 emissions, right? How does that happen? And of course, that's because in order to do these computations, right, we need electricity. And the electricity comes from a variety of sources. And some of those have CO2 emissions, right? And even if you could imagine that, your specific pot of electricity was entirely coming from renewable sources, by using those sources, you are still causing emissions, right? Sort of indirectly, because you're taking some of the electricity from the grid. So I don't want us to imagine that, we can say, well, my grid over here is great, so I don't have to worry about this. I think this really is a universal problem with long-running computation. And so, what I try to walk through with my class is, how can we even think about this, right? What is it that we would want to measure if we were going to really try to quantify some of the environmental impact of the code that we're writing? And what we're really going to look at is the energy used, right? Which is power times time. And the way that we do that is we're going to look at sort of an assumed CO2 equivalent per kilowatt hour. And that ends up depending on the local energy grid. So this is sort of what the mix looks like in Pennsylvania, which is where I am. And so you can see we do actually have some amount of the grid that's low carbon, but in Pennsylvania, it's also a lot of natural gas and coal. So given these sort of emissions rates, right, we can then go ahead and quantify what, say, a specific algorithm's CO2 emissions are, right? This is obviously an approximation, but I think it's a useful approximation because it can make it just a little bit more concrete so that we can understand what the impact is that we're having, right? And so we would start by saying, okay, how do I determine the energy consumption? How do I determine the kilowatt hours? Well, we need to find the power used and the time taken. And then figure out where this computation was done, right? So if it's being done on the cloud, then it's the relevance of that local group, right? Wherever the local grid, wherever that computation is being done is important. And then based on that energy grid, right, we need to look at what the composition was of where the energy sources were and what that means the CO2 emissions was in order to generate that energy. And the way that I integrate this into a data structures class, and I also do this when I teach algorithms, is in terms of thinking about how this relates to our usual notion of time complexity, right? And it turns out that it's very related, which is useful, obviously, in terms of the curriculum. It's very related, and the way that it differs is essentially in the details that big O notation will often hide, right? But which are still useful to think about. And so, again, I often brainstorm these with my students when we think about, right, okay, so often in big O notation, there'll be some hidden constant, but obviously the hidden constant matters in terms of the sort of measured wall clock time, and it also matters in terms of the resulting energy usage. The location obviously also matters, right? As we were just discussing, the local grid composition is really important here. So that's unusual, right? If you're thinking about normal time complexity. But a bunch of other things that we're used to thinking about also come into play, right? The computer speed, the specific input size, right? What the value of n is, and so on. And the way that we have students think about that is as part of, so either sort of in a more advanced context in algorithms, it would look a little bit different, but at the intro level, obviously we often like to have them do searching and sorting, right, with a whole bunch of various algorithms, and then look at the resulting time complexity, right, and say, okay, which sorting algorithm worked better in which context. It's that usual sort of assignment, but you can additionally have them track the emissions of the various algorithms, right? So I like to have them graph sort of, n versus time and n versus emissions, and sort of look at how those change. And again, they'll often look pretty similar. Time and emissions do end up correlating. But having them measure it in terms of emissions allows them to sort of see the environmental impact and the connection to that. And there's a nice package that I was also involved in creating called Code Carbon that allows you to do this sort of with that very simple snippet of code that I put on the bottom of the slide there, right? So it does sort of a decorator, and then it dumps out the resulting emissions calculations to a CSV file. And then the students can, process that CSV file to put it into a graph in, whatever graphing program they want to use. It's also, I think, useful, though I haven't done this in class as much, to help students sort of understand the fuller context of emissions. This package also has a way to sort of visualize what the emissions would look like wherever you moved them in the world, right? So it can sort of automatically detect your location and then give you the emissions based on your local location. But then it can also show you a map and say, okay, if you were able to have performed this computation in this place, right, what would the resulting emissions have been? And then it also gives sort of example emissions, right? So, I think that it's hard. One of the difficulties in teaching this is that it's hard for all of us to understand, okay, that many, kilograms of CO2, right? What does that really mean? Is that big? Is that small, right? It can be hard to understand that. And so the package and the visualization that it provides also sort of gives equivalents, right? This would be the equivalent to driving a car this distance or watching this many hours of television or that type of thing in terms of the expected CO2 emissions. I also wanted to sort of quickly mention in closing, right, that there are a lot of other ways to incorporate this. So I wanted to give sort of two examples of how to think about this. But in my own class and in the classes my colleagues have also taught, part of what we've been trying to do is really think about ways of injecting these ideas throughout the curriculum, sort of no matter the assignment. And as I was saying at the beginning, that doesn't necessarily have to be an in-depth examination of an ethical dilemma. I think that it's useful even just to introduce students to the idea that these problems that we're having them do have real world impact, right? And can allow them to examine the world around them, right? So, one of the assignments that we do is on polling data, right, for elections, and students put that information into max heaps, right? And then try to pull the data out to find out who's winning as polling data about the local election changes, right? And, that's not as much sort of an ethical conundrum, but it does allow them to understand how these data structures relate to other things they might care about in the world, right, and in society. Finally, I wanted to mention a few good things and some less good that we have to face when we're teaching these types of assignments. But starting with the good news, at least what I found and what I've also heard from my colleagues is that students really like these assignments, right? They feel much more relevant than, say, some of those classic intro assignments of, calculate all of the Fibonacci numbers from 1 to 100, right? They feel important in a way that draws students' attention. And that, as I said earlier, I think is really useful for us later when we're teaching machine learning, right? I think it gives the sort of necessary background. On the other hand, they need to be handled really carefully, right? So, part of the reason why we're planning to add sort of a full discussion section dedicated to just talking about the societal context of the ProPublic article is because students have said to us, it doesn't feel like you were dedicating the time in class. And if you don't dedicate the time in class, then we can't really believe that you care about it, right? Then it seems like sort of a token add-on instead of being something that you are willing to potentially sacrifice some computer science content in order to teach, right? In other words, what they were sort of trying to express to us is that it's not enough just to insert this into the curriculum, right? If we want to indicate that we actually care about these ethical issues, the way that we indicate that best to students is by taking actual time to demonstrate that we care about it and to have the real discussions that are needed. I also just want to note sort of logistically that, some of the ways that we handled various concerns you might have, right? How do you grade these types of assignments? Largely, we were grading for correctness, right? Because at the intro level, that's sort of the types of things that we were asking them for. In terms of pacing, this does take additional time. I think that the way that we've integrated it directly with the assignments, I don't think it's taking another entire class's worth of time, but it does take time. And I think really importantly, it is additional work that the students need to engage in intellectually, and they need that sort of thinking time. One of the other things that I found sort of transferring assignments between colleagues, right, is that it's important to provide materials for your colleagues, right? If you're going to develop an assignment and then hand it off to them, they might not be as familiar with the societal context. And then finally, obviously, student buy-in is really important. When I've been teaching these materials, I found that student buy-in was really easy, right? They were really excited about these materials, but I think it also helps to highlight the real world relevance, right? In terms of sort of understanding data, in terms of their interests in a wide variety of topics, and also in terms of the sort of growing number of internships that are related to these questions. So finally, I just want to, again, mention, right, I think that it's really useful to do these sort of data-driven real-world contexts and emphasize the human and societal context, even in data structures. And so with that, I wanted to leave you with a few sort of resources in case you're interested in thinking more about these. So I've been part of a Mozilla Responsible Computer Science group, and we've put together a playbook on how to do this type of thing. As you'll see there on the left, there's like a long list of different topics that people have sort of written, like, say, 2 to 3 page primers about, right? How do you integrate these topics into your classes? So if there's something that you've been wondering about, it's probably in the list. If not, there's still a chance for you to add it. So I encourage you to go to that website and sort of read through there and see if any of those materials are useful for you. And then all of the materials that I've mentioned today are also available at that link, responsibleproblemsolving.github.io. And I am constantly trying to remember to update it. So if there is something that I mentioned that is not up there, please feel free to just shoot me an email. And with that, I'll say thank you so much. And I would love to hear your questions.
Thank you so much. Please join me in thanking Sorelle for a wonderful talk. So now we'd like to make some time for questions. I see one here in the HackMD, and again, I will put that link. So the question, Sorelle, is when discussing the effects of data on the inference being made, for example, with respect to the risk of people being arrested again, to what level are the students exposed to the aspects of experimental design, i.e. with respect to confirmation bias or including observable parameters to help falsify the hypothesis?
Yeah, it's a good question. I mean, so I'm teaching a computer science class, right? So, you know, I imagine incorporating this into a statistics class would be very different, right? So unfortunately, you know, it's interesting. I so far haven't sort of formally included that in the way that I'm teaching it, right? I'm not sort of additionally formally teaching experimental design. And so, you know, what often ends up happening is that students who have taken, say, you know, a psychology methods class or a statistics class or something else will bring in some of that knowledge to discussion, right? Because I'm teaching at a liberal arts college. So my students have taken sort of a wide variety of related disciplines. But I think it's an interesting suggestion to think about how to incorporate that more. And I think also, you know, that's, you know, I guess I would also note that a lot of the types of things that I'm doing in data structures are really sort of, in some ways, a precursor to data science. And I think that question is really sort of pointing towards that discipline and might be really interesting to incorporate into a class that's more focused on
that. Peter? You have a question?
Yeah, just to comment on the answer. Thank you, Sorelle, again for this great talk. So I asked this question, you just answered. And my comment would be, maybe it's good that you don't mention experimental design, but rather point students away that they explore this on their own. I mean, this is how I understood your presentation, that you define a context and then the students are there to actually explore this in a guided fashion. Is that correct?
Yeah, I think that's true. I mean, you know, I guess what you're hearing in my response is that I always struggle with sort of how much of good experimental design and sort of generally good practice in these disciplines that are not computer science, it's sort of appropriate to bring in when computer scientists are sort of trying to understand data that's coming out of that context. Right. You know, and it's the same thing that I struggle with in terms of thinking about the historical and societal context. Right. I want the students to understand as much as possible about the data set, because when you're looking at data, that's the responsible way to act. But, you know, we obviously can't cover everything. Right. And so, you know, I guess largely what I try to emphasize to them is the responsible thing to do is to understand your data set and the context and the questions that you're asking.
Thanks.
Other questions before I ask mine? Sure. So Sorelle, you mentioned that this is a collaborative effort. Was that a challenge to find willing co-conspirators, if you will? Or can you speak a little bit more about the collaboration and how it's started?
Yeah, so there's sort of two aspects to the collaboration, and I'll sort of take them separately, right? So one is this sort of like between institutions collaboration. And that really happened because I was talking with Sunny Kamara at Brown and Suresh Venkatesubramanian, who at that point was at Utah, but is now at Brown. And, you know, the three of us sort of come from a sort of an algorithms background, broadly construed. And we're interested in thinking about, you know, how do we integrate these questions into a data structures and algorithms curriculum, right? And so despite our sort of different institutional contexts, because we were all in sort of a similar research conversation around these questions and care about thinking about how to integrate that into our teaching, we all wanted to do that. So that was sort of how that collaboration was formed. And then, I think the other collaboration is within my institution, right? And so that is sort of mostly my other computer science colleagues, but also my colleague in environmental studies, John Wilson, who was very helpful in helping me understand what was going on with the energy impact, right? And I think, in those cases, I'm lucky to have wonderful colleagues who also really care about these issues. And so, I think within the computer science department, those collaborators were largely other people who were going to be teaching the class, right? And so I said, okay, I'm going to be teaching this class, and while I'm teaching it, I want to add in a whole bunch of these ethically related assignments, and then you're going to teach it next year, and I'd like to pass it off to you, right? And wonderfully, my colleagues were really sort of willing to engage in that conversation, and think about, okay, well, now that I've sort of taken on these assignments, what works for me, what doesn't, right? What additional materials do I need? Because one of the things that I found really hard is, because I study risk assessments and racial bias and algorithms, there was a lot of context there that I just naturally bring into the classroom, right? When I passed that off to my colleagues who study other things, right? There was a bunch of context that they didn't necessarily just automatically know. And so, I actually found that useful for me in terms of developing the materials, right? Because they could ask me questions and I could say, oh, right, yeah, I didn't really explain that. Like, let me, try to give you some additional resources that will help you, but will also obviously help the students.
Sorry, I'm once again learning that typing fantastic answers from people and unmuting myself on Zoom is a challenging pandemic thing I have not mastered yet. I don't see other questions, but I did want to just surface this comment that's in the HackMD. The commenter writes, great content. The idea of wiring the ethical aspect into a practical assignment is really amazing. We made the experience and got the feedback from the students that theoretical treatment is sometimes relatively boring, especially in the context of a machine learning course. This was not my comment, but let's thank Sorelle again for a lovely talk. And we will take another break before our third speaker.
Thank you, everyone.